Hi, welcome to my video on division of monomial square root radicals, part 3. Simplify a square root radical when the radicand is a fraction. Notice this is not a whole number now, so it's a fraction. So root a over the root of a over b can be written as the root of a over the root of b. So that brings us back to the previous video. And some examples. Do not rationalize denominator. So I'm just going to rewrite them. This is the root of 2 divided by the root of 3. This is the root of 5 divided by the root of 6. This is the root of 7 divided by the root of 2. And this is the root of 10 divided by the root of 11. So notice I'm just rewriting them as a root over a root, because by rights, they say in math, you should not have a fraction underneath a radical. So you can write it as root a over root b. Practice write each as root a over root b. So do work these answers out and press play. So pause the video and work each of them out, and then press play when you finish. So this is root 13 over root 2, root 7 over root 5, the root of 3 over the root of 10, the root of 21 over the root of 17. So again, rewrite the fraction underneath the root as the root over root. Simplify each by rationalizing the denominator. So this one becomes the root of 3 over 2 becomes the root of 3 divided by the root of 2. Now, to rationalize, we have to multiply by root 2 on top and bottom. That gives us the root of 6, and root 2 times root 2 is 2. And this one becomes root 4 over root 7. But the root of 4 becomes 2. I can simplify it over root 7. Now I multiply top and bottom by root 7. And that gives us, make sure that's a 7 now. So that gives us 2 root 7. And root 7 times root 7 is 7. Notice this fraction. What happens if I reduce this fraction that's here? So if I make this 2 into 10 goes 5, 2 divided into 6 is 3, the fraction is smaller. So now if I rewrite root 5 over root 3, the numbers are smaller. So I multiply by root 3, multiplied by root 3, the answer would be root 15 in the numerator, and root 3 times root 3 is 3. So reducing this fraction inside of here first gives me smaller numbers to rationalize. And 36 and 49, 49 is a prime number, 7 times 7. So this is the root of 36 over the root of 49. But the root of 36 is 6, and the root of 49 is 7. So I don't have to multiply it. It automatically simplifies. Notice the root of 7 over 21. 7 goes into 7 once. 7 goes into 21 3, so I get a smaller fraction. So that's the root of 1 over the root of 3. And the root of 1 is 1, and the root 3 can't do it, so we multiply top and bottom by the root of 3. So 1 times root 3 is root 3. And root 3 times root 3 is 3. Notice we can't cancel here because that's irrational and that's rational. So simplify this fraction first. It makes it easier. F, 9 and 22. 9 got 3 times 3. 21 has no factor of 3. So this is the root of 9 divided by the root of 20. And the root of 9 is 3. 20 is a 4 times 5. So the root of 20 is 2 root 5. So we multiply top and bottom by the conjugate, which is root 5. Root 5. Conjugate of 2 root 5 is root 5. Multiply the numerator, 3 times root 5. Done. Multiply these two. 2 times 1 is 2. Root 5 times root 5 is 5. So that gives me a 10. And 3 and 10 can't reduce. You cannot reduce the irrational number root 5 with the 10. You can only reduce right here. And 3 and 10 has no common factor. Practice. Practice means pause the video and work them out. So you got 9 to do here. Here we go. Do one at a time. So 3 over 5 can't reduce, so that's the same as root 3 divided by root 5. Conjugate of root 5 is root 5, top and bottom, to balance it. So that gives me root 15 over 5. Roots 7 over 6 can't reduce, so that becomes root 7 divided by root 6. And I multiply top and bottom by the root of 6. The root of 6 is the conjugate of root 6. So 7 times 6 is 42. Root 6 times root 6 is 6. Notice 42 can't break down because that's a 7 is prime. So 6 got a 2 and a 3, so there's no perfect square factors. And in this one, the zeros cancel, so I get the root of 1/2 when I cancel the zeros. And that's the same as the root of 1 over the root of 2, which is root of 1 is 1 over root 2. So I cancel the zeros divided by 10 to get a half. The root of a half is the root of 1 over 2, which is 1 over root 2. So I multiply by root 2 over root 2. So 1 times root 2 is root 2, and root 2 times root 2 is 2. Remember, try to reduce the fraction before you split it. And 25 got a 5, can't do it. So this is, you can't reduce these two. So this is the root of 25 over the root of 28. And that becomes, root of 25 is 5. 28 becomes 4 times 7. So that's a 2 root 7. The conjugate of 2 root 7 is root 7. Root 7 top and bottom. 5 times root 7 is 5 root 7. And 2 times 1 is 2. Root 7 times root 7 is 7. So that gives me 14. Can't reduce. And 8 and 36 can reduce. 4 goes into 8. 2 times 4 goes into 36, 9. So reducing this, dividing both numbers by 4 makes a smaller number. So this becomes the root of 2 over the root of 9. So that becomes the root of 2 over 3. So it's rationalized. Reducing it first makes it easier. Now you could have gone the other way, but you still would have got there. Let's have a look at that. What about if you said, well, let's do the root of 8 and the root of 36. And what is the root of 8? Root of 8 is 4 times 2, so that's a 2 root 2. The root of 36 is a 6. And the denominator is root 36 of 6, so 2 into 2 goes once, 2 into 6 goes 3, so 1 times root 2, and over 3. So if you reduced by 4 first, it made it easier. But if you didn't, you just had to do more work. Just be careful. And root of 18 divided by 15, that can reduce down. 3 into 18 goes 6. 3 into 15 goes 5. So that gives me the root of 6 over the root of 5. And we multiply that by root 5 over root 5. So root 5 times root 5 is 5. Root 6 times root 5 is root 30. And you cannot reduce these because that's irrational, that's rational. And 800, look at the big numbers. But if you divide by 100, you get the root of 4 over the root of 3. Dividing, reducing it down, so 400 over 300 is the same as the root of, let's go with the root of 4 over 3 first. Divide by 100 first gives you the root of 4 over 3. Now, the root of 4 divided by the root of 3, and the root of 4 is 2. 3 can't break down. So we multiply top and bottom by root 3. So it's 2 root 3 over 3. So divide by 100, give you the root of 4 over 3. Split that into the root of 4 over the root of 3, done. Simplified root 4 to a 2, then multiply by the conjugate. And leave this last one here. Now, we have a root, so we have to follow BEDMAS. PEMDAS. BEDMAS, PEMDAS. So we have to do underneath the root first. So I have two parts. I have a numerator and a denominator. So in the numerator, following this, I have to multiply before I add. So that's 4, add on, 40. 5/8 are 40. In the denominator, when I simplify this, I have to do that power first, exponent. So 2 cubed is 2 times 2 times 2 is 8. So let's continue. I have to simplify the numerator first. So that's a 40. Then I have to simplify the denominator, which is a 12. And notice that 4 goes into both of these. 4 into 44 goes 11. 4 into 12 goes 3. So simplifying the numerator and your denominator is done. Then I divide by 4 because 4 is a factor of both of these. Now I got a small fraction to deal with. So that's root 11 over root 3. And the conjugate of root 3 is root 3, top and bottom, to balance it. So root 11 times root 3 is root 33. And root 3 times root 3 is 3. And you just, that's a 1. You could have 1/3 root 33. Because there's a 1 there. You could have root 33 over 3 or 1/3 root 33. But you cannot cancel that root and that, because that's irrational and that's rational. Think about that. And that brings us to the end of another video. And if you like my video, click the like button, the subscribe button, and the notification bell, because there's more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find out more information about me, my videos, and my content that's on my YouTube channel. Thank you very much for viewing my video. Bye-bye.